Forward value of R as the sum to infinite terms of the following infinite series is 44 over 9. Let us begin. So here we have a series. We're going to denote the sum as S infinity. The series is 3 plus 5R plus 7R squared plus 9R cubed. And it goes all the way up to infinity. Now this is neither an arithmetic series nor a geometric series because it does not have a fixed common difference, nor does it have any fixed common ratio. However, it is composed of two sequences. One of the sequences is going to be in arithmetic progression and the other sequence is going to be in geometric progression. Let's try to quickly understand it. So from the first term, if we consider 3, from the next term we pick up 5, from the third term, that is 7R squared, we pick up 7, and from the fourth term we pick up 9, and the rest of the terms we immediately see here that these terms are going to be in arithmetic progression. And if we consider from the first term 1, from the second term 5R, we consider R. From the third term we consider R squared. From the fourth term we consider R cubed. Then these terms are going to be in geometric progression. Now, if they're in geometric progression, we can also define the common ratio. So the common ratio that's going to be equals to R. Now this is very important here. We'll take this common ratio R and we're going to multiply each terms of this infinite series with R. So that's going to help us obtain R times S infinity. Now R times the first term 3, that gives us 3R, but we're going to write it below 5R. Next we consider 5R, the second term, multiplying with R gives us 5R squared, and we place it below 7R squared. Then we come to the third term, 7R squared, multiplying with R gives us 7R cubed. And then we have the rest of the terms. Now here we are going to perform the subtraction. So we have 1 minus R multiplied to sum up to infinity. This is going to be equals to, we have 3 added to 5R minus 3R, so that's going to be 2R. Added to 7R squared minus 5R squared, so that's 2R squared. Added to 9R cubed minus 7R cubed, that's 2R cubed. Added to the rest of the term. So here, we'll keep the first term as it is, 3. Now, if we consider the second term onwards, then the sum is a geometric series. The sum of this series is going to be a geometric series whose first term is given by 2R and the common ratio that's given by R. And we know there's a standard formula for finding out the sum to infinite terms of any geometric series. So that's given by the first term divided by 1 minus the common ratio. So that means for our case, we have 2R divided by 1 minus R, which means the sum of the infinite terms that will be equal to, we're going to divide both sides with 1 minus R. This gives us 3 over 1 minus R added to 2R over 1 minus R whole squared. So let's combine them. So we have sum of the infinite terms that will be equals to, combining them, we get the common denominator of 1 minus R whole squared. So in the numerator, we have 3 times 1 minus R added to 2R. So sum of the infinite terms that's equals to 3 minus R over 1 minus R whole squared. So this is going to be the sum to infinite terms. And now our next task will be to obtain the value of R. And it's given here that the sum to infinite terms, that's 44 over 9. Now, using the fact that sum of the infinite terms, that's equals to 44 over 9, that means we get 44 over 9 equals to 3 minus R divided by 1 minus R whole squared. So let's cross multiply. So we have 1 minus R whole squared multiplied to 44. So that will be equals to 9 times 3 minus R. So that's 27 minus 9R. Right. Furthermore, we can simplify to get R squared minus 2 times R plus 1 multiplied to 44. That will be equals to 27 minus 9R. So we have 44R squared minus 88R plus 44 equals to 27 minus 9R. So 44R squared. Now we're going to transpose this negative 9R to the right hand side. So that's going to give us negative 79R. Added to, so we have 44 minus 27. So that's going to give us 17. So that's equals to 0. Now this is a standard quadratic equation. We can either use the quadratic formula or we can factorize it to obtain the value of r, which I'm leaving as an exercise for you to try out. So r comes out to be equals to 1 over 4, or it comes out to be equals to 17 over 14. However, of the two values of r, we have to reject 17 over 14 because this particular value of r tells us that r is greater than 1. But in the problem, we know that the sum up to infinite series, so it is giving us a finite value of 44 over 9. Now that is only possible if the absolute value of r is less than 1. So that only one of the value is less than 1. So that means thus the value of r must be equals to 1 over 4 such that the sum up to infinite number of terms for the given infinite series comes out to be 44 over 9.